So like I promised in the previous lesson, we're going to factor cubics. So in the previous lesson, we talked about the remainder theorem. And I kind of alluded to the fact that the remainder theorem was a build-up to helping us to factor a cubic, because if the remainder was 0, that would mean your divisor is very special. I really don't want to give it away, but you know what? We'll get there in a few minutes. Now, before we talk about some more theorems, I just want to quickly refresh your memory. Why is it beneficial to factor a cubic or quadratic or any polynomial for that matter? So why do you want to go from standard form to factor form? Okay, or just in general, we're just going to say, why do you want to factor? Okay, so there's two big reasons. Graph polynomial function, because once it's in factored form, you can have the zeros. Solve word problems. Okay, because once you can factor a polynomial function, that you can solve a polynomial equation by factoring, and generally those word problems require you to solve a polynomial equation. But we're getting ahead of ourselves. I just want to remind you why it's very important to be able to factor. Okay, so factoring is very powerful. If you cannot factor cubics in this unit, you will most definitely not do very well on this test. Okay, so let's take a look. We have this table here. I have a quadratic and 2 cubics. So I wrote down the polynomial functions, and in fact I also factored for you. I told you that for x squared plus 3x plus 2, there are 2 factors, x plus 2 and x plus 1. And for the polynomial x cubed plus 2x squared minus 5x minus 6, these are the 3 factors. If you were to factor it, these would be the 3 factors. And same could be said for the last polynomial. These are the 3 corresponding factors that make up that polynomial. And I also showed you some relationships. F of negative 2 equals 0. This kind of makes sense from what you learned previously, because what is this really saying? X plus 2 is a factor, so f of negative 2 equals 0. Well, of course, because x plus 2 is a factor. Why does this make sense? Because remember what we learned in the previous lesson? If x plus 2 is a factor, you need this to be equal to 0, because the remainder must be 0. That's what it means to be a factor. The remainder is 0. Okay, so you can go on and on and on. So x plus 1 is a factor, so f of negative 1 is 0. Let's see, 2x plus 1 is a factor, so f of negative half is equal to 0. So what do you see? What does a relationship see when x minus b is a factor of p of x? Well, it's on the previous page, on the next page, but I'll write it again. If x minus b is a factor of p of x, then p of b equals 0. You need it to be 0 because you need the remainder to be 0. That's what it means to be a factor. I don't know, let's say 5 is a factor of 25 because 25 divided by 5 has a remainder of 0. Now if you divide by ax minus b, no problem. Ax minus b is a factor of p of x. Hopefully remember p of b over a, because b over a will make ax minus b equals 0. So this is actually a special circumstance or special scenario regarding the remainder theorem. Okay, so if the remainder happens to be 0, it tells you something special about your divisor. It tells you that your divisor is a factor. Okay, so we gave it an extra name. Okay, we called it factor theorem. Okay, factor theorem, I really don't want you to see it as something entirely new. It's an extension of the remainder theorem. It's basically saying if the remainder is 0, your divisor is a factor, which is nothing new. I mean, you learned that in elementary school. Okay, now it's just with polynomials instead of real numbers. Okay, so don't think of it as something that's brand new. If the remainder is 0, your divisor is a factor. Okay, so I have a polynomial here, f of x, some quartic, doesn't matter. And they're asking me if x plus 2 or x minus 7 or x plus 3 is a factor. So you know what? To see if x plus 2 is a factor, I need to see what f of negative 2 is. What is the remainder when I divide by x plus 2? So I'm going to find f of negative 2. Can I use long division? Absolutely. But there is no way that's happening. Yeah, you can also use synthetic division, but no way that's happening. Oh, this quartic is long. Okay, so 16, this is negative 8, negative 24, this is 4 times negative 7, minus 28, and then plus 54, minus 18. Hey, it's 0. What do you know? So what this is saying is when I divide by x plus 2, the remainder is 0. So since f of negative 2 is equal to 0, therefore x plus 2 is a factor of f of x. Okay, what about x minus 7? Is x minus 7 a factor of f of x? Let's try to find f of 7. I got a bad feeling about 7. And we're going to talk about why I have a bad feeling about 7 in a few minutes. Okay, so, yeah, that just, algebraically, just doesn't look right. So 7 to the 4, 7 cubed is 343, minus 40, that's not 343, minus 27 times 7, minus 18, 2,880. Now, since f of 7 does not equal 0, I care that it's 2,880. All I care is not 0. So since it's not 0, then I'm going to conclude x minus 7 is not a factor of f of x. Okay? I don't care. It's 2,880. All I know, it's not 0. Okay, last one. Let's check x plus 3. So I'm going to find f of negative 3. If I divide by x plus 3, is the remainder 0? So find f of negative 3, and we'll see what the remainder is. Okay, let's see. Is the remainder 0? So that's going to be 81, and that's going to be negative 81. It's negative, yep, and then 9, 7, so it's minus 63, and then plus 81, minus 18. Hey, it's 0. So, since f of negative 3 equals 0, therefore x plus 3 is a factor. And just a side note, of f of x. Just a side note, later on when you factor your own cubics, you're going to be very excited when you get zeros. Okay, you really want to find that factor. Okay, you don't want to spend all day guessing around because that would be problematic. Okay, so now we know how to check whether we have a factor or not. But now there's a second problem. Okay, where do I begin? So the factor theorem is great to check if a factor is, if the binomial is a factor of the polynomial, okay, if we have a factor or not. But the problem is, for example, let's say we have f of x equals 3 squared plus 2x squared minus 6x plus 7, and we're asked for the factors of the polynomial. Where do I begin? Okay, I mean, can't you just check any factor in the world? You can say x plus 2, x minus 2, x plus 3, x plus 4, x plus 7, x plus 10, x minus 2,000. You have to have a starting point, okay? So that's why we're going to introduce another theorem. Okay, this is called the integral zero theorem. Okay, that's basically telling you if the leading coefficient is 1, okay, of this polynomial, you can actually just take a look at the constant term, and that will give you the possible zeros, the possible integer zeros. Integral in this case means integer zeros. Okay, so I'll try to explain to you how the integral zero theorem came about. So there's a lot of more complicated proofs, but I'll try to keep it simple. Okay, so we have x cubed plus 7x squared minus 4x plus 4. By the way, I'm not saying it is factorable, okay? But let's assume it is, okay? If it is, my three factors here will be, okay, let's say I can break it to three linear factors, will be x something, x something, x something. Now, the values that I'm going to put here for the constant term of each binomial, what must they be? They must be factors of 4, right? Because I have to multiply it by 4. Okay, if they were integers, if they were factorable, okay? So, if it was factorable, they have to be factors of 4. So, let's go back to something that you're very good with, like quadratics, okay? Like, if this is clearly, okay, I made something that's pretty simple. Simple trinomial is factorable. So what you're doing, you know what? Sorry, I have to change. It's too simple. Let's do 12 instead. So let's do multiplies at 12. So like the values you put here have to multiply to 12. It could be 1 and 12, 2 and 6, 3 and 4. And you can do negative, negative as well. But all I'm saying is the numbers here have to be factors of 12. Okay. Now, obviously, you know it's 3 and 4, but that's besides the point. All I'm trying to say is they have to be factors of 12. So for the same reason here, these values here have to be factors of 4. So that's basically the integral zero theorem. By looking at the constant term, and of course your leading coefficient is 1, okay, by looking at the constant term, you can determine the possible zeros, okay? So in this case, the possible zeros, possible test values for B will be plus minus 1, plus minus 2, plus minus 4, okay? So let's say the plus 1, plus 2, minus 2. Ooh, that doesn't work out. Let's do minus 2 and then minus 1 here, right? See, it could be x minus 1 or x plus 1. So that's why you try the possible values of B with plus or minus 1. And then x plus 2, x minus 2. So that's why you have possible values for B could be plus minus 2. Now I didn't write down the possible factors. It could be x plus 4 and x minus 4. That's why it could be plus minus 4 for B. So by looking at the constant term, you can see what the possible zeros are, okay? All right, so let's factor. X cubed plus 2x squared minus 5x minus 6. The leading coefficient is 1. So I'm just going to write down what the possible zeros are. The possible zeros for f of x, okay, and we'll look at the constant term, could be plus minus 1, plus minus 2, plus minus 3, plus minus 6. So this is where the guessing game begins. So you can try f of 1, f of negative 1, so forth and so on. Now I would personally recommend you try smaller numbers because finding f of 6 is a little more challenging than finding f of 1. Okay, so like for example, 1 is pretty easy, you can do it in your head because you don't want to write it down and get a failed attempt. Now since I'm trying to show you why it's good to get the right attempt on the first try, I'm going to do a poor attempt. Okay, I'm going to try to find f of 6. Okay, now why is f of 6 a bad idea? Because f of 6, I'm very confident that f of 6 is not 0, and that would be a bad idea. You want f of something that will give you 0, and f of 6 will not give you 0. So Let's see, f of 6 is 6 cubed plus 2 times 6 squared minus 5 times 6. I'm doing the calculations, a rough calculation in my head, and I'm not seeing 0. Okay, I don't know what it is, but it's not 0. So it's 216, that's 36 times 2 is 72 minus 30 minus 6. Yeah, that's 252. That is not good. That was a failed attempt. That was essentially not a very good use of time. So let's try something else. So we tried 6, no good. So I would personally never have tried f of 6 to begin with, okay? I would have tried 1 or negative 1 in my head. Let's try 1. 1, 2 is 3, and then, yeah, 1 won't work out. So let's try negative 1. So negative 1, this will make that negative 1, this will be 7 and 7. Yeah, negative 1, negative 1 works out. Okay. So that's negative 1. Now I'll just write down all the calculations. Right? 2 plus 5 is 7. Negative 1 minus 6 is negative 7. So we're looking good. Since f of negative 1 equals 0, therefore x plus 1 is a factor of f of x. Okay? Alright, so we know that we can break this into 3 linear factors. Okay, we found one of them. So I don't know about you, I don't know how you feel about that guessing game, but I really don't like that guessing game. Okay, that guessing game was not fun. So what you can do is you can choose to keep playing the guessing game. There are 2 more factors there. You can find f of 2, check if f of 2 is 0, check f of negative 2, check f of 3, check f of negative 3. But I certainly will not do that, okay? There's a much easier way to go about to find the other 2 factors. So what I'm going to do is I'm going to use synthetic division. Can I use log division? Yes, but I'm going to use synthetic. Because I'm going to use synthetic and break this cubic into a linear times quadratic. And why is that a good idea? Because you have those grade 10 factoring skills that can further break that quadratic into linear times linear. So let me show you. Let's do synthetic here. So 1, 2, negative 5, negative 6. And then what is the factor? Negative 1. So x plus 1 means it's negative 1. So 1, negative 1, 2 plus negative 1 is 1, negative 1. This is negative 6, 6, 0. So after I do synthetic division, I'm very confident I was correct because I got a remainder of 0, there's a remainder of 0 here. So this basically self-checks. If I made a careless mistake, I would have found that. Okay, so f of x equals x plus 1 times x squared plus x minus 6. I break the cubic into a linear times a quadratic based on the fact that you learned in the first lesson. Your dividend is equal to your divisor times a quotient plus a remainder, but your remainder is 0. Okay, and now, like I said, I'm very good at factoring quadratics. Simple trinomial, what multiplies a negative 6 and adds to 1? That's 3 and negative 2. And there you go. I factored my first cubic. Well, you factored your first cubic. Isn't that beautiful? So aside from that little hump or that little guessing game you have to play in the beginning, after you find your first factor, you stop guessing. Please don't keep guessing. Find the first factor, use synthetic division, and then you can fully factor your cubic. So take your time to digest that, but now unfortunately we have another problem. Okay, so the first problem was, where do I begin? How do I find these factors? Okay, and the answer to that question was the integral zero theorem. You look at the constant term, and then you can basically go narrow down from all the real numbers in the world to hopefully, well, the factors of your constant term. Hopefully they're not too many factors, because if you imagine like this was like, I don't know, 144, there's a lot of factors, okay? So that's not a fun guessing game. So hopefully the constant term doesn't have too many factors. But nonetheless, it's still much better than all real numbers, okay? So, like I said, there's one more problem. The integral zero theorem is great, but unfortunately it only works when leading coefficient is 1. But I assure you, many of the examples that you'll be doing in the homework do not leading coefficient of 1. So if that's the case, then we have to learn one last theorem, which is called the rational zero theorem. Okay, so it's actually very similar to what you did for the integral zero theorem. So you know what, I'm just gonna make up some examples to help you out. Okay, so let's, and of course, let's do 6x cubed minus 7x squared plus 5x minus, let's do a nice number here. 1 second, sorry. Let's do 15. 15 is beautiful. Okay, so like I said, just like before with the integral zero theorem, I'm going to break it down to 3 factors. Okay, so I don't know what the 3 factors will be, but the coefficient of x, okay, has to multiply to 6. And the constant term has to multiply to 15. So, well, sorry, let me say it one more time. The coefficient of x has to be a factor of 6, and the constant term has to be a factor of 15. So, I don't know, let's say the coefficient of x could be 3, and let's say it could be 5, and this could be plus minus, okay? So 3x plus 5, 3x minus 5. So you can keep building your other factors, but I'm going to just look at the first factor. So the coefficient of x has to be a factor of the leading coefficient, and the constant term of your binomial has to be a factor of your constant term of the polynomial. So I know that was wordy, but your factor is basically controlled by the leading coefficient and the constant term, as opposed to before it was only controlled by your constant term because the leading coefficient was 1. So that's why if the factor is in the form of ax minus b, a has to be a factor of your coefficient and b has to be a factor of the constant term. So that's why our zeros will be, if ax minus b is a factor, then the zeros will be b over a. So this is called a rational zero theorem because your zero is in a form of a rational number. So it's b over a because the factor is ax minus b. So this is very similar to what you did with the first unit. When you wrote the factor, you wrote down the corresponding zero. So ax minus b is a factor, then b over a is a zero. So take your time, digest that, but it really helps if you give yourself some numbers to work with, okay? And then create some sample factors. By the way, this is not factorable. Okay, 3x plus 5 is not a factor. I'm just saying it may be a factor, okay? And that's all this is saying. These are all possible zeros, okay? All right, so we got a few more factoring questions. So 3x cubed plus 2x squared. So first I'm going to do let f of x equals 3x cubed plus 2x squared minus 7x plus 2. Okay, because I need to use function notation, so I'm going to let f of x equals that cubic. All right, so I'm going to write the possible zeros. I don't expect you to do this all the time, but since we're just starting off, I'm just going to identify the possible numbers I can guess. So the possible zeros will be plus minus, okay, so it's b over a. Let me just show you one more time. B over a. So b are the factors of the constant term and a are the factors of your leading coefficient. So that'll be 1 and 2 and 1 and 3. So we 1 over 1, 1 over 3, 2 over 1, 2 over 3. So we have plus minus 1, plus minus 1/3, plus minus 2, plus minus 2/3. This is a simpler way to write it though. Okay, so I personally won't test the rational numbers. I will personally test the, I'll test the integers. Okay, because testing rational numbers, can I check 1/3? Yes, I can, but finding f of 1/3 is a little more complicated, and I can't do that in my head. It'll take me a longer time to find f of 1/3. Can I find f of 2/3? Yes, but I want to make my first guess easy, so I'm going to try like 1 and -1. You know what? Let's do 1. That'll be 2. 1 works out. Beautiful. 1 works out. Trust me, you are going to get very excited when you find one of the 3 factors, because the guessing game is not fun. Especially on tests, you don't want to waste too much time guessing the right factor. So since f of 1 equals 0, therefore x minus 1 is a factor of f of x. I'm going to teach you a secret shortcut hereafter. So what you can do from here is you can use long division. And we said that was a bad idea. So I taught you synthetic division. And you know what? Synthetic division is not bad, but there's something better. So what we're going to do here is called inspection. Okay, so I'm going to break apart this cubic by inspection. Okay, or just using the identity, using the logic that this is a dividend, and I have a divisor, and I can find the quotient. So f of x is equal to x minus 1. Okay, and I don't know what this is, but this is a quadratic factor. Okay, I don't know what the terms are exactly, but I know it must be a quadratic factor. Why? Because linear times quadratic will get me that cubic. So there are 3 terms. There's an x squared term, an x term, and a constant term. If I fill in those 3, then I'm done. So the first term must be 3x squared. Whoa, that was magic. How did I get 3x squared? Because I'm looking at what f of x is. I need to get to 3x cubed. So this has to be 3x squared. What else is it going to be? Right? It's an identity. It has to work out. All right. So now I'm going to fill the constant term of the quadratic factor. So I want to multiply by, I need to get to 2. So what am I going to put here for the constant term of the quadratic factor? Well, -1 times -2 will get me 2. Now the last term, or the middle term of this quadratic factor is the hardest to come up with. It's not that hard. So we're going to see. So -1 times 3 will give me -3x squared. Now x times this mystery x term, okay, that's some x term. So x times this term here, the middle term, will give me another x squared term. Now when I collect these 2 terms, the -3x squared with this mystery x squared term, I have to get 2x squared. I have to get it, okay? Otherwise, then I'm wrong. So I have -3x squared, but I want to get to 2x squared. So guess what? I'm going to put 5x here. 5x, because 5x squared minus 3x squared will get me 2x squared. And if you really don't trust yourself, what you can do is expand, and you'll see if you really have f of x. So this way, you're basically using an inspection technique to help you find the quotient. So I would argue level 1 would be long division, level 2 would be synthetic division, and level 3 would be inspection. You can find the quotient without doing long division or synthetic division. It's much faster. In the beginning, it'll be a little slower, but with a few repetitions, you'll be very good at it. And it's worthwhile because all we're doing in this unit is just factoring cubics. Okay, so now complex trinomial. So hopefully that hasn't escaped you. So here I want a 2 and a 1. I want to make 6. 6 minus 1 is 5. Perfect. There we go. All right, let's see. 15x cubed minus 14x squared minus 39x plus 14, fully factor it. So I'm going to first of all use function notation to help me out. Let f of x equal 15x cubed minus 14x squared minus 39x plus 14. I'm going to write down the possible zeros one more time, but when you look at the homework solutions, I don't write it down. Okay, I just want you to factor. I don't need you to tell me the possible zeros. By you guessing correctly, I'm assuming that you know what the possible zeros are. Okay, but we're looking at the factors of the constant term, plus minus 1, 2, 7, and 14. And then factors of 15, 1, 3, 5, 15. Okay, those are your possible zeros. Quite a few of them. So yes, the rational zero theorem gives me a lot of different rational zeros to test out, but I always start with the integer zeros. It's just much easier. I'm thinking 1. Let me check. For 1, does 1 work? Let's see, 15 minus 14 minus 39 plus 14. No, that is not a good idea. Let me check. It was 2. 2 works out. All right, we successfully guessed 2 is our 0. So since f of 2 equals 0, therefore x minus 2 is a factor of f of x. Okay, that's factor theorem. All right, so now that I have my one factor, I can figure out the other 2 factors. And like I said, I'm just going to do it by inspection. So f of x, my cubic, must be equal to x minus 2 times this mystery quadratic factor. All right, so the first term of the quadratic factor is 15x squared. Why? Because I want to multiply to 15x cubed. The constant term will be negative 7, because negative 2 times negative 7 will get me positive 14. All right, what about this middle term? So right now I'm going to make negative 30x squared. But I don't want negative 30x squared. I want negative 14x squared. So I want to put plus 16x here. So let's check. This will give me negative 30x squared. This will give me 16x squared. Negative 30x squared plus 16x squared. When I collect those like terms, I'm going to get negative 14. Beautiful. Works out. All right. Complex trinomial. Let's see. Let's try 5x and 3x. And then 7 is 21. 21 and 5 will make my 16. So plus, minus. Let me triple check. 21x minus 5x is certainly 16x. All right, that's it. Done factoring. So I think the slowest part of this question is just guessing the correct factor. Once you have the first factor, finding the other 2 is pretty straightforward. But like I said, you have to successfully find the first factor by guessing a little. And really try to look at your cubic and really think about the possible guesses. Don't just try random numbers like 7 or 14, because those aren't really good guesses. Okay, so we're at the end here. Let's just quickly look at the differences between factoring a quartic and a cubic. We didn't factor any quartics in this worksheet, but it's really no different than factoring a cubic. We would have, so factoring a quartic. Factoring a quartic will require you, to guess 2 factors successfully instead of 1. So it's a bit more work to factor a quartic, because after you successfully guess 1 factor when you have a cubic, you break down the cubic into linear times quadratic. And once you see quadratic, you're home free. But for a quartic, once you successfully guess 1 of the factors, you break down the quartic to linear times cubic. and unfortunately you have a cubic left over, which means you have to do one more round of guessing. So factoring a quartic or a quintic or any degree higher is just more work, but the strategy would remain the same. Okay, so ultimately, once you have the rational zero theorem and the integral zero theorem, you're ready to factor a polynomial of any degree. It might be more work, but you can do it. So in summary, okay, the first theorem you learn is the remainder theorem, and that allows you to find the remainder without doing long division. But you soon realize that you really don't care for the remainder. You only care about the remainder if it's zero, and that leads us to the factor theorem. So factor theorem tells us you have a remainder if the remainder is zero. It's pretty self-explanatory. And then we talked about the integral zero theorem and the rational zero theorem. So even though you know whether you have a factor or not, you need to have some starting points where to guess. And the integral zero theorem and the rational zero theorem gives you those starting points.